So shout out to all of my students there. I hope you guys are doing well. This is, again, a continuation, a little bit of math here. You're trying to figure out what are the percentages of different elements in a given compound. Okay, so that's all you're looking to do in terms of the math. The big picture, you got sodium chloride in here. So this is what we're going to be solving for. You've got 58 grams of sodium chloride in this weighing boat. So it's 1 mole of sodium chloride. And the question is, in this 58 grams, how much sodium do we have as a percentage? And how much chlorine do we have as a percentage? So we're looking at the masses and we're trying to calculate the percentage. And then we'll modify that a little bit in addition to calculating the percentages. So the important thing is you need to know the formula. You need to be able to write the formula, hopefully, and be able to read the formula accurately. You're then going to calculate the molar mass. And then from there, you're going to do the percentage calculation. So you absolutely need to be able to calculate molar mass, and that's what we're going to do here. So let me get my glasses on. Hopefully you guys are going to turn off your notifications. Is that right, Ryder? I'm counting on you. Okay, and here's the chemical. So the chemical is sodium chloride again. Okay, that's the chemical we're working with. The formula is NaCl. At this point, you should absolutely know that there is 1 sodium and 1 chlorine. So this should look familiar. We're going to just write this out. So the first symbol is sodium, Na. Chlorine is the next element in here. That's the next symbol as well. And the element is chlorine. So please write these out. It's extremely helpful, especially when you're learning initially. So we're concerned in the moles, so we're not really going to be talking in terms of just a single molecule of sodium chloride. We're looking more at a mole. So the number of moles in 1 mole of this entire compound, so in 1 mole of this entire compound is what we're talking about, in 1 mole of sodium chloride. Okay, so we're interested in 1 mole at this point. We're not looking at 1 molecule. So in 1 mole, you're going to have 1 mole of sodium and 1 mole of chlorine. Okay, so at first glance, you're going to say, hey, it's 50-50. 50% is 1 of each. Not true, because we're interested in the weights, not just in the number of atoms. Okay, so right here are the number of moles. So yes, you've got an equal molar ratio, 1 mole of sodium to 1 mole of chlorine. That means you got 1 of each, but that does not mean mass percentage-wise this is the same, and you'll see in a second. So again, for this example, I'm just rounding, but once we get into more examples, you always want to use out to 2 decimal, correct number of significant figures based on your handy-dandy trusty periodic table. So on the periodic table, we're going to look for sodium and we're going to look for chlorine again. Sodium is 22.990 for our purposes right now. While I'm explaining this to you, I'm going to round this to 23. And chlorine is 35.453. Remember, I need the atomic masses, not the atomic numbers. Atomic numbers are on the top, the smaller number. So sodium is 23 and chlorine is going to be 35. So the weight is 23 grams. And for chlorine, it is 35 grams. Please remember, this is the weight of a whole mole of these chemicals. This is not a weight of a single atom. Okay, this is a weight of 1 mole of sodium atoms. And again, over here, this is the weight of 1 mole. 1 mole of chlorine atoms weighs 35 grams. We multiply these two together. You end up with 23 grams and 35 grams. You add this up, you end up with 58 grams, which is great. Okay, so we got 58 grams. So now the question becomes, what is the percentage of sodium in sodium chloride? Okay, another way of asking this question is, in 100 grams, how much of sodium would you have? Okay, and how much of chlorine would you have? That is analogous. That is the same thing as saying percentage. Okay, if you calculate it for 100 grams, you could also write it as a percentage. So here's how you solve this. For those of you good at math and very well versed with percentages, This is probably a breeze, but let me belabor it, and I want to make sure everybody understands this crucially. Okay. Again, I'm hoping you guys. Hey, Henry, have you turned off your notifications there? I'm hoping you have. Okay. So 23 divided by 58 multiplied by 100. Okay, so I took 23, divided it by the molar mass, 58. Again, I multiplied it by 100. Now here's the deal. If I was looking for 100 grams, this answer would be in grams. So let me just write down that. So if I divide that, that is equal to 39.7. Okay, so 39.7. Now you can write that. So that's your answer. So it's 39.7 grams. Or you could write it as a percentage. Either one works. Let's repeat this for chlorine. It's 35 divided by 58. So again, 35 divided by the molar mass, which is 58. And you are multiplying that by 100. Okay, and that is going to give you 60.3. Now, in this example, it's in grams, so you can write grams. But if I asked you for the percentage, that's what we were originally talking about. So imagine it's exactly the same. Only thing is, instead of writing grams, you would write 60.3%. So, overarching concept. In sodium chloride, you have got sodium and you've got chlorine. Okay, and in 1 mole, which weighs 58 grams. So in 58 grams, there's 1 mole of sodium chloride, the molecules of sodium chloride. And in that 1 mole, 39.7%, so 39.7% of sodium chloride is sodium, and 60.3% is, believe it or not, chlorine. So it's not a 1-to-1 ratio. Weight-wise, there's a huge difference. So it's almost 40% is sodium and roughly 60% is chlorine. Now, if I asked you the exact same question, but I said instead of 58 grams, in 50 grams, how much sodium do you have? So you're going to set this up in a very similar way, and I want to make sure you see this as well. So the question here is in 50 grams. So previously it was in 100 grams. Now we're solving for 50 grams, so we're going to set this up in a very similar way. 23 divided by 58. But this time, instead of multiplying by 100, we multiply by 50. Okay, and that, so let me plug that in so we can do it together. So 23 divided by 58 is 0.39, so 0.4 roughly. Okay, so we've got that number, and you multiply that number by 50, and that equals 19.8 grams. So 19.8 grams is sodium. And again, same deal, 35 divided by 58 multiplied by 100 is equal to, so 35 divided by 58 is equal to 0.60 multiplied by, whoops, typo here, guys. This should have been 50, not 100. Need to be paying attention. So into 50 is equal to 30.2 grams. So again, I made a typo here. Wasn't paying attention here. So in 50 grams, we've got 30.2 grams. So you're multiplying both of these fractions by 50 if your question is in 50 grams as opposed to 100 grams. Hey, were you guys paying attention? Did you catch that error I made? I hope you did. Lastly, let me just repeat this, and hopefully you're taking good notes on this, because this is kind of the bread and butter of chemistry. Synonyms for molar mass. There's a whole bunch of them. Ones I use interchangeably. So instead of saying molar mass, you'll hear me say formula weight. I have a habit of saying that. Whenever I say that, I mean molar mass. The other one that you will often hear is molecular weight. These are the most common ones. Okay, and they basically refer to the exact same thing, which is molar mass. So these are all equal to molar mass. So if I ask you what is the molar mass of sodium chloride, you would say 58 grams. If I asked you what is the formula weight for sodium chloride, same deal, 58 grams. And the molecular weight is also 58 grams. So 3 different terms for the exact same number. To recap, we looked at a chemical called sodium chloride. It has the formula NaCl. NaCl has 1 sodium, 1 chlorine. If we are looking at a mole of sodium chloride, we are then saying in 1 mole of this chemical right here, NaCl, we've got 1 mole of sodium and 1 mole of chlorine. If I'm talking about a single molecule, 1 single molecule of sodium chloride, I would then say I have 1 atom of sodium and 1 atom of chlorine. Slightly nuanced difference there, but it's important that you recognize that. If I'm looking for the weight of 1 mole of sodium chloride, I add up the gram values from the periodic table, multiply them by the number of moles, I get 23 grams, 35 grams, I get 58 grams. So 58 grams is how much 1 mole of your chemical, sodium chloride, weighs. We then calculated the percentage of sodium and chlorine in that 58 grams. So the percentage of sodium, based on this calculation right here, is 23 divided by 58, and you multiply that by 100, you end up with approximately 39.7% sodium. You kind of repeat the same process, but this time with chlorine. 35 divided by 58, so this weight divided by 58 multiplied by 100 gives you 60.3%. If you're not looking for a percentage, but you're looking for a defined gram weight, whatever weight of sodium chloride you are given, so if I pulled out this amount right here, and this is approximately 5.8 grams. Let's see if the camera will get this. I'm not sure it will, but that's 5.8 grams. If I had 5.8 grams, instead of multiplying this by 50, I would multiply this by 5.8. But in this example right here, I used 100 grams and I used 50 grams. So this is the amount of sodium that's present, and this is the amount of chlorine that is present. Hope that was helpful. Just remember, it really helps to practice this and also to teach somebody else this concept. That's one of the best ways to learn. Hope that was helpful. Smack that like button, guys, and I'll see you on the other side. And just remember, if it ain't chemistry, that's just stamp collecting. Bye.